Picture this. You are standing in your kitchen, you reach down to grab a single, lightweight fork off the floor, you sneeze with the force of a gentle breeze, and suddenly your lower spine explodes with the intensity of a grenade going off in a drywall factory. Congratulations! You have just experienced the ultimate irony of the human spine. You are participating in the single greatest flex in evolutionary history. You are walking upright on two legs. You have free hands to hold a smartphone, drive a car, or eat late-night fast food while walking through a parking lot. But in exchange for that absolute luxury, Mother Nature handed you a structural column that is basically a stack of Jenga blocks held together by expired jelly donuts and pure audacity. We like to think of human evolution as this majestic, polished upgrade where we slowly transformed into biological masterpieces. But the human spine is not a masterwork. It is a rushed, duct tape patch job written on legacy code that was originally designed for a horizontal fish. And if you have ever had your back completely throw itself out because you sat in an office chair slightly askew for 45 minutes, I have got news for you. It is not your fault. You are simply paying the tax for a 7 million-year-old engineering mistake. So how did the exact thing that made us rulers of the planet end up as a ticking time bomb inside our own bodies? Well, to understand why your lower back hates you, we have to talk about how evolution completely botched the blueprint. Let us rewind the clock. For hundreds of millions of years, four-legged mammals had it figured out. Think of a dog, a horse, or a chimpanzee. Their spines are built like suspension bridges. The four legs act as sturdy vertical pillars, and the spine hangs horizontally between them. Gravity pulls straight down across the entire arch, distributing weight evenly. It is simple, it is stable, and it works. Then, about 6 or 7 million years ago, our early hominin ancestors looked at the trees, looked at the open savanna, and said, "Yeah, no, we are going to stand up." Now, if evolution were a proper engineering firm, it would have halted production, scrapped the suspension bridge design, and built a completely new vertical support beam from scratch. But evolution is not an engineer. Evolution is a broke, sleepy college student finishing a project at 3 in the morning using whatever random garbage is lying around the room. Instead of redesigning the spine, evolution took that horizontal suspension bridge, rotated it 90 degrees vertically, slammed our massive, heavy brains right on top of it, and whispered, "Good luck." And predictably, everything went wrong. Because when you turn a bridge into a flagpole, gravity stops pulling across the structure and starts compressing it straight down. Suddenly, all that weight, your head, your chest, your arms, that second slice of cake, is no longer distributed across four legs. It is stacking down directly onto a tiny strip of bone and cartilage in your lower back. To stop us from instantly tipping over like a top-heavy broomstick, evolution had to slap on some emergency quick fixes. In apes, the lower back is short and stiff, usually made of just 3 or 4 lumbar vertebrae. That keeps their spines rigid so they can swing through trees without snapping in half. But for us to walk upright without bending our knees and crouching like a goblin, we needed flexibility. So evolution added an extra lumbar vertebra, bringing our count to 5, and forced the lower back to curve inward toward the stomach. This created the human S-curve. The upper back curves out, the lower back curves in, and the pelvis tilts. This S-curve is actually brilliant in theory. It acts like a giant spring, absorbing shock when you stride and balancing your heavy skull right over your hips. It is the reason you can walk 5 miles without collapsing. That is the flex. But here comes the massive L. By curving the lower back inward, evolution concentrated almost all the compressive force of your entire upper body onto 2 specific vertebrae at the very bottom, L4 and L5. If your spine were a corporation, L4 and L5 would be the 2 unpaid interns doing 95% of the labor, while the neck and shoulders take all the credit. And what is sitting between those heavily stressed vertebrae? Your intervertebral discs. You can think of a spinal disc as a little rubbery jelly donut. The outside is a tough, fibrous ring, and the inside is a squishy, fluid-filled gel center designed to absorb shock every time you take a step. When you are a little kid, these discs are rich, juicy, and full of blood vessels that deliver fresh nutrients. But around the time you turn 20, right when you start having to worry about adult responsibilities and credit scores, your body makes a catastrophic decision. It completely cuts off the direct blood supply to your spinal discs. I am not joking. After skeletal maturity, your spinal discs become entirely avascular. From age 20 onward, the only way a disc can get oxygen and nutrients is through passive diffusion. It essentially acts like a dry kitchen sponge. When you walk around and move, you squeeze metabolic waste out of the disc. And when you rest, it slowly sucks up nutrients from the surrounding tissue. This means your lower back shock absorbers are decaying in real time. They cannot repair themselves effectively. Once you damage a disc, it stays damaged. You are walking around on permanently deflating, aging jelly donuts. And remember how I mentioned sneezing earlier? In the 1960s, a legendary Swedish orthopedic researcher named Alf Nachemson inserted tiny pressure sensors inside the lower back discs of living human volunteers to measure how much load they were taking in different positions. He found that standing up puts decent pressure on your discs. Sitting down and slouching increases that pressure significantly. But do you know what caused one of the highest pressure spikes ever recorded in his lab? A violent sneeze. A sudden, forceful sneeze can spike the internal pressure of your lumbar discs to over 150% of what it is when you are just standing normally. The rapid contraction of your core muscles compresses the spine so violently that it can literally pop the outer ring of a worn-out disc, spraying the inner gel outward like a squished pastry. That is a herniated disc. And here is the absolute wildest part. The inside of a spinal disc has zero pain receptors. The jelly center can literally be tearing itself apart, and you will not feel a single thing until that squishy gel oozes out of the side and crushes directly against your sciatic nerve root. Suddenly, your brain receives a localized electrical shock of raw agony shooting down your leg, and you are lying on the floor reconsidering every life choice you have ever made. Your spine's security alarm is not even installed inside the room where the fire starts. It is installed in the hallway outside. Because these discs are basically squishy water balloons, they react constantly to the environment. Every single day you spend walking around on Earth, gravity relentlessly compresses your spine. Throughout the day, water gets squeezed out of your discs, and by the time you go to bed at night, you are actually up to half an inch shorter than you were when you woke up. Then, while you sleep horizontally, the pressure releases, the sponges soak up fluid, and you inflate back to full height by morning. If you want to see how dramatic this is, look at what happens when you take gravity out of the equation entirely. When astronauts spend weeks in microgravity on the International Space Station, their spines stop being compressed. The discs swell up to their maximum capacity, and astronauts can grow up to 2 inches taller in space. But as soon as they land back on Earth, gravity violently slams their vertebrae back down together like an accordion, causing intense back pain and making them significantly more likely to suffer a disc herniation during readaptation. Gravity is constantly trying to crush you, and your spine is barely holding the line. Now you might be asking, if this design is so flawed, why has evolution not fixed our backs by now? Well, for one thing, evolution does not care about your comfort. Evolution does not care if you are 40 years old, groaning every time you bend over to pick up a dropped shoe. Evolution only cares about one thing. Did you survive long enough to pass on your genes? Millions of years ago, when our ancestors were hunting on the savannah, average lifespans were shorter, people were moving constantly, and nobody was sitting in an office chair staring at a monitor for 8 hours straight. The S-curve was good enough to get our ancestors to age 25, let them reproduce, and keep the species alive. As far as natural selection is concerned, mission accomplished. Whatever happens to your back after age 30 is simply not evolution's problem. In fact, recent evolutionary biology studies led by researchers analyzing 3D models of human bones revealed something mind-blowing called the ancestral shape hypothesis. Scientists discovered that people who suffer from intervertebral disc herniations often have vertebrae that are shaped measurably closer to chimpanzees than people who do not get herniations. Let that sink in. If you are prone to throwing your back out, it might literally be because evolution left the ancestral ape settings on your lower spine. Your body is trying to run modern vertical software on hardware that still thinks it is climbing a tree in the ancient past. And as if the decaying jelly donuts and ape-shaped vertebrae were not enough, evolution left us with one final, petty insult right at the base of the column: the coccyx. Otherwise known as your tailbone. Over millions of years, as we transitioned to upright walking, we lost our physical tails. We did not need them for balance anymore. But instead of completely deleting the bone structure, evolution just truncated it into a tiny vestigial cluster of fused bones tucked right between your glutes. It does not help you balance. It does not help you walk. Its primary biological function in the modern era seems to be collecting localized trauma when you slip on an icy sidewalk, or causing excruciating, dull pain when you sit on a hard wooden bench for more than 20 minutes. Evolution took away our cool, functional tails that could hold objects, but forced us to keep the bone stub that exists purely to punish us for sitting down. When you stack it all up, the human spine is a masterpiece of tragic compromises. It is the reason we built civilizations, painted the Sistine Chapel, and sent rockets into orbit. Standing upright freed our hands, elevated our vision, and unlocked everything that makes us human. It is our biggest flex. But every time you stand up from the couch and hear a sound like dry bubble wrap popping in your lower back, just remember, you are carrying the living receipt of a messy, 7 million-year-old evolutionary rush job. So if your lower back is throbbing right now, do not beat yourself up. You did not sleep wrong, and you are not just getting old. You are a horizontal animal trapped in a vertical world, fighting a daily war against gravity. And considering we are doing all of that on top of ancient suspension bridge parts, The real miracle isn't that our backs hurt. The real miracle is that we are standing at all,